So polyatomic ions are, in some ways, a lot like molecules, and in some ways, quite different. They are particles that are held together by covalent bonds in the same way that molecules are. However, overall, they have a charge due to there somehow being an imbalance of the total number of protons and electrons. So essentially, either they are missing an electron or they have gained a couple of extra electrons along the way, which has given the particle an overall charge. But the atoms themselves are held together by covalent bonds. The substances that have these polyatomic ions in them are classified as ionic compounds. So normally when we talk about them, we're talking about them as ions, but sometimes the IB will like to throw a question at you to ask you about which of the following contain both ionic and covalent bonds. And if you get a question like that, usually it's on paper 1, where you're looking for both ionic and covalent bonds. Then you're looking for the presence of a polyatomic ion. So at this point, you should have the 7 polyatomic ions from the syllabus memorized, including ammonium and nitrate and carbonate. Those are 3 very common examples. But these 3 things, they're made of nonmetals bonded to one another through covalent bonds, but overall they have a charge. So like ammonium has a charge of +1, nitrate -1, and carbonate 2-. So they have a charge, yet they're held together by covalent bonds. But then overall, this compound, ammonium chloride, is an ionic compound. So it would have a crystal lattice of alternating positive and negative ions. Drawing Lewis structures for polyatomic ions is almost identical to drawing them for normal molecules. The one thing is you have to change the number of electrons available for sharing. This is step 2 in the 7 steps for drawing Lewis structures. Cations have less electrons because cations are positive, meaning they've lost electrons, and anions have more electrons. So you have to you kind of go through the 7 steps as you normally would, but then you're either going to take electrons away or add electrons to them in order to figure out how many bonds to draw. And then in the end, after you've drawn the structure, you have to put brackets around the drawing and put the charge in the upper right-hand corner. So we'll go through these examples right here. With NH4, the number of electrons that you need to have, the nitrogen needs to have 8, and the 4 hydrogens need to have they need to have 8 in total because it's 4 times 2. Each hydrogen needs to feel like it has 2. So that means in total, we're looking to feel like we have 16. Now, N brings 5 to the table, and 4 H's bring 4 to the table, which is 9. And then here's where the charge comes in. Ammonium has a +1 charge, which equals 1 electron lost. So instead of 9, you have to take 1 away from that, and that means that you actually have 8 to work with. Okay, so 16 minus 8 equals 8 electrons that need to be shared, which means 4 bonds. And so that makes sense. In the drawing, we would end up doing N in the center with 1 bond to each hydrogen. We know hydrogen only forms 1 bond anyways, and we put the H's in. And there's the proper Lewis structure. We would check that nitrogen has its octet, which it does because it has 4 covalent bonds. We'd also check that we've used the correct number of electrons, 2, 4, 6, 8, which matches the number that we are allowed to use. This would get 0 points though on the IB exam. In order to get the points, you have to add these brackets around it and put the charge in the upper right-hand corner. And now it gets the full mark. We can do the same thing for CO2. So both carbon and oxygen want to feel like they have 8. So that means we've got 4 times 8 electrons. We need to feel like we have 32 electrons. Carbon brings 4 to the table, and 3 oxygens each bring 6. So that's 18 electrons. So we have 22 to work with. But we also have a 2- charge, which means extra 2 electrons. And so that means we actually have 24 to work with instead of the normal 22. 32 minus 24 is 8, which equals 4 bonds. So now I know I need to draw 4 bonds. I'm going to put the carbon in the middle because there's only one of it. I've got 3 oxygens, so I'm going to kind of spread those out. And I have to spread out 4 bonds to 3 things, so let's give 2 of them to one oxygen, and let's give 1 to the other oxygens. I then check, okay, carbon has the octet, so carbon's all set, but these other ones need their octets, so that means 2 pairs on this oxygen and 3 pairs of lone pairs of electrons on the other ones. And now every oxygen has a full octet. And then I count, have I used 24 electrons? Well, there's 8 in the bonding pairs here, and then 10, 12, 14, 16, 18, 20, 22, 24. So I have indeed used 24. To get the mark, I add the brackets, and I add the charge. Now, a little bit different focus when we write this number. Notice I wrote the number first. Here's the 2, and then I drew the minus charge. When you draw charges as superscripts, you always put the number first and then the negative or the positive sign. That's different than when we drew oxidation states and we put the plus first or the minus first. So a little annoying thing to keep in mind. But that really is all there is to drawing polyatomic ions. You just have to pay attention and either use one fewer electron or use extra electrons based on the charge, and then add brackets and the charge on the outside of the brackets.